That's going. All right. So, like before, I'm going to be doing a video version of this live, so you can check it out after the fact if you want. And I'll have this camera set up so you can see what my hands are doing, just because we can't gather around very easily right here to do all that. So I put a link at the top of the Google Classroom right there. If you scroll down just a bit, a few announcement stuff. LSU is doing some summer things, and I was asked to share this with my students, and this is me doing exactly that. Basically, it's like a summer camp, and there's a bunch of different classes, and the ones I know the most about it's essentially a condensed version of this course, so that probably wouldn't be very interesting for most people. And then kind of the same thing with the sound design course that we'll have next year. But you can check out other stuff if that's interesting to you. And that's that. I said I would share it, and I did. There's going to be... Let's start with the bell ringer stuff today first. So for the bell ringer, very first thing, I want you all to start taking out your kits for your Arduino stuff, and I want you to, here's today, build this diagram. This is kind of where we left off last time. And just so you all know, I don't have the time to put away everyone's kits every day, so we'll be ending at 2:15 while we're doing this, just so you have time to pack everything up and put it in the box. So kind of remember some stuff about what I said about how these all line up, but with this diagram, it should show you exactly what gets plugged into where. And this generator made a brown resistor. Remember, if you have the blue ones, it would be red, red, black, black instead of this one. So I'll keep this on the screen for a bit. Maybe all about 5-ish minutes. said, I'll still be giving you a few minutes, but you'll know that you've got it working when, if you press the button, the light turns on. So that's how you'll know that you've wired it up correctly. You can kind of see it right here, but when I click the button, the little light lights up. So that's how you'll know that you have got it working correctly. Yes. You should. Yours are blue, right? Get the red, black stripes. Yeah, so, well, technically it would be red, black, and then brown, I think. But the blue ones just have more stripes than the brown ones, but they can have the same resistance. Everyone should have the right resistor sizes from last class. I've got a few extra, but I don't have enough to give out a bunch every class period. All right, so for the sake of time, I'm going to give you all just a little bit more, but not a ton. And then I'm just going to go through building this, because again, this is where we left off last class. If you do check out, it's probably going to get mad at me when I switch to this program and form an infinite loop. But if you watch this after the fact, or if you watch it now with a little bit of a delay, I'll have up in this top corner my little camera here, so I'll be pointing out where stuff lives and how it all works. So that might be useful. I tried finding a way to just display the camera up there, and it was getting angry at me, so I'll try to work something out for next time, but it did not want to go. We'll need that in a second. Alright, so for the sake of time, I'm going to keep going. If you weren't quite able to get it, that's okay. I'm going to show you and kind of walk you through everything right now. The first thing that's kind of important is this 5-volt and ground from the Arduino board. You're going to need that, otherwise none of the power from your computer is going to enter into the system and it's not going to work. If they fell out, just put them back, but these cables I gave you yesterday for bridging both sides, you're going to need that. That's going to make your life a lot easier. As for exactly how it's laid out, it can vary. This is just one possible configuration. But we've got coming from the power here, so from the plus to the positive side of the LED. Again, that is if you're looking at it, the longer of the two wires. Let's get that back in there. Get in there. Get in there, damn it. There we go. So that's connecting from the positive to the longer of the two LED wires. I then have the other wire connected to the same row as our resistors, the same ones from last class. What's new, though, is this push button that we've introduced. And this is connected to the same row as the other end of the resistor. And I have it kind of bridging this middle gap here. You don't necessarily have to. It just is they're perfectly sized for that, and it makes it easy to jump back and forth. Yes? You should have push buttons. They're tiny little things in a bag. If you don't, I've got a few extra you can borrow. Yeah.
In the bag with like the red looking chips. Red.
Yeah. If it turns out it doesn't have any, let me know. I've got a few extra. Oh yes. Yes. Watch your step. I've got a long wire now.
I've already seen it.
Yes. Sorry, I forgot to mention that. All right. So, but now we have this this switch here, and this is a useful thing. If you remember from my talk last class, a switch, or specifically a push button, is a kind of switch that has a momentary state, meaning it's only connecting the circuit when it's pressed. So when we press it, it's going to connect the diagonal pins here, and then that'll just go to ground and complete the loop for the electrons to flow through. You may have to play around. If you didn't line it up diagonally across the button, it may or may not work. So I have this one here that I'm going to kind of hold up on the camera, if anyone wants to come look at it real quick. But I've got coming from the power of the Arduino to the plus, and then from the plus, this one I actually have going backwards. So it's from the plus to the switch, but it works the same way. And then it's going diagonally across it, so it comes in on the left side, it leaves on the right side. Resistor, LED, LED to ground. So when I press it, it lights up. So again, if you're watching the video at home, you can ignore this part of the board, but whenever I press it, the yellow light turns on. So again, if you're watching me do the video right now, it'll probably be delayed just a second, but you can see that kind of going right there. If this diagram was a little confusing, that's okay. We'll get used to looking at these as we go along. I tend to like these just because it's very graphically clear what goes where and how it's plugged in. So we'll get more practice doing this, and we'll actually make one more of these by the end of class. So, does anyone not know how I got the button to trigger the LED, or need some clarification? Yeah. Oh yeah, the buttons may be picky about fitting in there. I would set it, let's see if I got a better picture of a button that I can put on the screen here. Button, that's what we're doing in a second. Buttons. Where are you at? Buttons, resistors. Nope, it must be in this one. Oh, adding buttons and switches. That would make my life easy. Okay, so you see how the buttons, the little prongs kind of go down and clip towards the middle? I would have, if you're putting it in the middle of the breadboard where there's this big groove, I would have them kind of clip in around that. Does that make sense? I think so. Yeah, cool. You got it. And then you may just have to really fit in there. Buttons are the things I have the hardest time keeping in these breadboards. I wish more kits came with the big ones, just because they're easier to work, but the smaller ones take up less space and they're cheaper. But anyways, okay, let's start jumping into it today. So last class we talked a lot about just how electricity works. We made some basic circuit that just electricity is running. And that's what we did today with the button here. We're controlling the flow of electricity, but we don't have any code to do anything with it. And that's what we're going to start with today. So there's a few things I want us to do first. If you go to the Google Classroom and you scroll down just a little bit, you'll see this post here with this Arduino.exe file. We're going to just make sure that this gets installed on the computers, because I tried doing this with the web editor, but the various school whatevers wouldn't let me install the right drivers. So we're just going to install the not web-based program and use that. So if you click on this and download it, it will download a program. And you may have to hit download anyways or whatever. Yep, click download. It's going to be a program, so it'll go to your downloads and it'll open up in the things. But you're going to get a like login bit of information that you need some username and password stuff. What I'm going to give you is technically secret information, so don't go around sharing it. In fact, it would probably be good just forget that I even mentioned it. And because it's secret information, I'm actually not going to mention it on the video. It's written on the wall over there, the username and password in order to install something. I should have made the capital letters obviously capital, so you can enter that in when it asks you for. Yeah, I thought it was kind of funny. I didn't pick it. That's set at the district level, but that is the secret information that's going to get erased after class, so they can't yell at me. And then once you've done that, basically you're going to get a little install wizard. Basically hit agree and yes to everything. You can pick wherever you want it to install, but it'll make a desktop icon and all that. But just be sure to hit yes for everything. And then when the little bar goes all the way over, you'll have the option to close out the installer. Once that's done, you'll be good to go for the rest of the year. So going forward, you're going to want to make sure you're on the same computer as you are today. These should be the ones that are normally there. But because they're only installed on these computers right now, you'll just have to manually reinstall that. And that'll just be time consuming if you have to do it a whole bunch. So give everyone a second to get through that.
Does it matter where the stop button is placed, or does it place that spot aligned with resistors and wires and all that?
For right now, it doesn't actually, no, it really doesn't matter, because the whole point is it's just stopping and starting the flow of electrons. As long as you have the other elements, everything's going to work fine.
So, but for setting where it will still function, right?
Yeah, if you wanted to put the button in between the resistor and the LED or before the LED, that would work. In the example I set up, and I have the physical one on the desk here, I've actually flipped it. So it goes from the positive to the switch, through all the stuff to negative down here. And it still works fine. Later on, that might not be the case, just because we'll be building code that's going to be responding to stuff in certain ways. All right, so again, make sure that you hit agree or accept or whatever on that installer window. It's going to ask you like 3 or 4 little, do you want to install this? And just say yes, because otherwise it's not going to work.
That makes sense to me. Like, I agreed to it once, makes me think I'm not going to agree to it the second time.
Yeah, it's slightly different things, so you have to agree to it each time. It's annoying, but it's a free program, so I can't complain. All right, so if you're ever at home or you have your own Arduino kit and want to do there is a, just at the Arduino website, there is a web editor. However, as you will see on this computer, it's not going to load properly because it needs a specific driver to work, but it's not going to work on these computers because it won't let me install it. So that's why we just did what we just did. Once you've hit agree to all the stuff, you will see an app. Should be just appearing on your desktop, but if not, you can find it in your apps and all that. But it says Arduino, and it's this bright blue circle. You open it up, and it pops up with this. Yours will probably be blank. This is going to show the code we're going to work with later on today. But what this will do is we can write the code that tells our Arduino board how to respond and send out electricity from our circuits. And that's what I'm going to kind of go through today up front. So if you want to pull these pages up on your on your computers, we're just going to the physical computing with Arduino section. All right, so there's a few things that I won't get into right now, but the concepts are similar, but a lot of things we type are different. We'll find that out as we're going through Arduino. I'm not going to go through all the details right now. All right, so most of this on this setup page we can ignore, just because it's going to, like we can't do the web editor stuff. But what I'm going to show you how to do right now is make sure that your Arduino is talking to your computer and everything is working. So in your, in your Arduino app that we just installed, if you go to File, Examples, and then it's under Basics and Blink. You're going to click on that one. And it's going to open up, again, you want the Blink Basic Example. I'll leave the menu on the screen for just a second, but it'll open this up right here. What this code is going to do, it's a very short code, very simple, and it's actually got all of just the same basic parts as our P5 code does. It has a setup function right here where it sets up what the pins do. And then it's got a looping function, just like draw, where it executes the same code over and over again. In this case, it takes a pin with the built-in LED and sets that to output. So it's going to send out electricity and values. The loop is going to write the value high to that pin, wait 1,000 milliseconds, and then write the value low, wait 1,000 more milliseconds. So we should see the light turn on for a second, off for a second, on for a second, off for a second. What you're going to do next is hit the upload button right here. And it's going to compile it, which means it's going to test the code to make sure there's no errors. A little message may pop up on your board about picking the right serial stuff. Just hit OK. Basically, each port on your computer has a different numeric value, so the computer knows what it's talking about. Excuse me. And it just needs to make sure that it's picking the right one. Let's see. So, like, if I was to hit, you just want to make sure the ports in Arduino board are correct. So if you hit Tools, you can see that it's port, in my case, COM3 is the name, and it is the Arduino Uno board. You may have a different port ID, but you should all say Arduino Uno right under board. But once that pops up, assuming everything is good to go, it'll say, Sketch uses 924, blah, 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 stuff like that, and it's all good to go. Now, if you look on your Arduino board itself, you should see a little light turning on and off on the board. So everyone should see that. This is on the board, not on the breadboard. I've got, just to make this a little bit easier to use, So for people watching this video, I've got it hooked up to where I have an LED mimicking that same light, just so it might be easier to use. Yep. So should be a little, I think they're orange by default on these boards, but you should be seeing a light pop up. Again, like this. If you don't see this, something has gone wrong. All right.
But I think mine is on before.
That's very possible. But now, basically, we've overwritten whatever code was already there, and we have set it to be this pace. While we're looking at the Arduino board, I just want to point out a few of the specific sections of it. You should see a pink button on the corner. This button basically shuts the board off and back on again. So if you ever run into an issue, you hit that and it'll reset it, and it'll still run the same code from before. The USB connector, for this class, this is also where we're going to get power, but you can hook up an external power supply to this if you need to. We can see the LED right here that is kind of built in, as well as the power LED. And then there's a few little banks of these pins right here that we can connect our cables to. They do different things. There's a section that's all related to power stuff. We'll get into the analog pins later, but we're going to start focusing on these digital pins over here. And some of them do different things, but we'll get into that as we go. There's a bunch of other stuff here, like a clock and some capacitors and other things that we don't need to get into that right now. These are the main important things that you should know exist, and at least vaguely where to find them. All right. I'm not going to go through the basics of electricity, but there is a page in the textbook that basically contains everything I mentioned in my PowerPoint slides last time. So you can check that out. What we're going to start talking about now is digital inputs and outputs. Essentially having our code be able to send and receive signals to manipulate electricity. Specifically with digital signal, basically it's a signal with a Boolean state. It's basically, is it on or is it off? And that's an extremely dumbed down version, but we're going to be playing around with ones and zeros and highs and lows and things like that. That we can get some more potential values, but again, mostly this class is going to be built out of that high and low stuff. As I pointed out before, there are the pins 0 through 13 on one side of the board that are all labeled digital, and that's what we're going to be using. What we have to do, though, is tell our Arduino board to either send or receive data from that pin. It's either going to send out a high voltage or a low voltage, or it's going to say, oh, I got electricity, or no, I don't. We have to tell it to do these things. You can't have one pin do both at the same time. It doesn't work that way. All right, so we've already got, so if you closed it out, open it back up again, but this Arduino example right here, this blink. So we can see that we're using this function here called pin mode. And this is what we do to tell it, to tell our pins, is this going to be something that we, send or receive data on? So what you tell it is the pin that you want to use and the whether it's an input or an output. In this case, the LED built in is like a system variable that just maps to the pin for the built-in LED. And then we set it to output. Then because it's an output, we can write data to it, meaning set it to a specific value of either high or low, because it's digital. So we just say in the loop, digital write, the pin you want to write, the value you want to write it to. So what I'm going to do right now, and I'm going to encourage you all to do with me, is we're going to add to this code right here. So I'm going to go to the very top, just kind of above this comment, and start typing. We can basically we can type in this just like our code editor. There's a few things that are slightly different because again this is built out of a different programming language, but the concepts transfer. So I'm going to say const, C-O-N-S-T, const, let's see, button pin equals, which ones do I want to use? Let's use 4 and 7. So 4, semicolon. This is one thing. If in P5 you don't type the semicolon at the end of the line, that's okay. It's still gonna work. In Arduino, if you forget the semicolon, it's not gonna work. So at the end of each command, you have to stick that semicolon there in order to see it. Let's also say const LED2 equals 7. These are going to be the pins on our LED on our Arduino that we're going to be using. I'm then going to go into the setup function. If you want to, you don't have to. That's just what I did. I'm going to go back into setup now and say pin mode. And then I'm just going to pull up button pin, comma, input in all caps, semicolon. Another pin mode, LED2, output. All right. So that's the first part. I'm going to leave that on the screen for just a second, and then I'm just going to minimize this. I'm not going to close it out. We're going to come back to that in just a second. But in this case, we're just storing these pins as a variable, so we can just refer to it by the name of the pin. You don't have to remember what each... Is the last one output? Output, yes. You don't have to remember what all the numbers are. You can just give them a name. So it's like, oh, this is connected to my button, or this is connected to my LED, or whatever. Yes. All right. So basically what we're going to be ultimately doing is setting up an LED to turn on when we hit a button. However, what's going to be happening instead is, instead of it being how we did before, where we clicked the button, it let the electricity flow through the circuit, it's now going to, the electricity is going to, it's going to automatically respond to whether or not we have hit this button. So again, I'm going to minimize this, but don't close it out if you do that along with me, because I'm just going to kind of show through a lot of the stuff we have on the screen. A lot of this code here I also have embedded into the page, and this web page is kind of just breaking down a lot of what we've just done. So let's see. Do we want to do this? I think we've done this one already. Of just here's a breadboard and making an LED circuit. But if you wanted to check out some more pictures of that, this one is basically just, hey, the LED works. This is what we ended class with last time. I need to fix this diagram, but it's kind of got the same idea. I have the red here going to the wrong pin. Yeah, now that I've noticed it, I can't unsee it. But all right, so let's move on. I want adding the buttons is what I want. So again, we'll be adding a button, and you should already have a button out. We can just reuse the one we did from the beginning of class. I won't get into switches today unless we just really want to. But again, a button, basically it just connects the 2 points whenever we press it. And then it goes back to its state when we let go. So we're going to start building up a circuit. The one I have first here on the page is going to be basically what we have already. It's pretty straightforward. What we're going to be doing instead is changing some stuff up. Well, that link died. I just want to find where's the page? There we are. This is what we're going to be doing right here. So if you wanted to scroll down and kind of look through some of this in text, you could get that up and going. Basically, what we're going to be doing is everything I've just said. So what I'm going to be doing here is, yes. Okay, well, get mad at me without int. Did I do that? All right. Const. At the very least, all right, yeah, so let's just go ahead and add the int to be safe. I guess technically you don't need the const, but basically in this program you have to define what kind of variable it is. So int is an integer, meaning a whole number. A const means it's a constant value that won't change, that can't be changed while the code runs. That's what that is. So go ahead and add an int just to be safe. Sometimes we can go there. So let's just add that. I'm just going to come back. All right. I'm going to add one more variable up here. So let's just say const button state. Again, I'm taking this from the textbook. This is going to be right at the top, right there with our other variables. Actually, instead of, I don't want const. I want, it's not const. Variable types. I think it'll just be int. Yeah, int. There we go. Int, so be int button state. And we can give it a default value of 0 as we go right there. So again, I've got int button state gets assigned 0. I'm then going to go here into the loop. I'm just making some space. And I'm going to add in a conditional. If and what we're going to check and see is if, I'm not in the parentheses, if the button state is equal to 1, then we're going to, basically we're going to then say, hey, turn on the LED. So we're going to say, we're going to need to call up digital write, because again we'll be writing out a value just like we have down below. So digital write, and this is going to be pin LED2, and we're going to write that to high, and that's going to be in all caps. Get that up for just a second. And then afterwards, I'm going to replace that with, so else digital write LED2, pin LED2, that is low. All right, so basically we're going to set this up so that way the output of this pin is going to respond to whatever the value of button state is. So now, again, I'll give everyone a second to finish typing. We're going to need to monitor what the input is. All right, so I'm going to just swap back here just to make sure I've got all this ready to go. do button stay. Yes, okay. Just wanted to make sure I didn't forget that. So what we're going to do is add in one thing before this statement here. And again, if you're looking at this on the textbook, you could probably find it very easily. But we're just going to say digital read. We're not writing, we're reading that, we're just getting the inputting data. And this is going to be from the button pin. All right, so again, this code is relatively simple, but we also have to worry about getting the circuit ready to go as well. So again, just to kind of briefly go through all of this, we set a variable to be the button pin and the LED pin, just so we don't have to remember the numbers, because that can get confusing when you have a bunch of pins that you're using. You can just say, oh, the green LED, or the pressure sensor and stuff like that. You don't have to remember which out of the 17-ish inputs or outputs on this device is what. We're also going to be checking the state of the button. In setup, we're setting each of the pins to be either an input or an output. And then in the loop, we are reading the incoming values from the button pin. And then we are, depending on whether it's high or it's 1 or 0. Actually, let me change that to high. We'll do it that way. I think it should work both ways, but if it's high here, then we're going to set the pin, the LED2 value to high. Else, meaning if it's low, if the button is not being pressed, it's going to go to low. And then everything else was just already in the template that we started with, and that's what's causing the light to blink. So if your code looks just like this, I'm going to hit upload. This is going to erase, and I've got an issue. What? Where do I not have LED2? If it's saying not declared, you're going to want to make sure that
If constant int LED equals 7, but no LED2.
In that case, because I have LED2 up here and it's all down here, so make sure that it matches where you say const int versus down there. Also, in this one, yeah. So what I have, this doesn't show lines, but up here it says, I'm defining the variable as LED2, so that everywhere else it has to be LED2. So if it doesn't match exactly up here, it's not going to work. Another thing I just realized, because I don't do Arduino that much actually, or when I do, it's slightly different things. For your conditional, make sure that it's only 2 equal signs and not the 3 that we've used before. Set it to 2, and that should fix some errors. And then you upload it, and it'll compile. And again, if it looks exactly like mine, can I make this any bigger? Then it'll upload without a problem. And there, actually, I've managed to fit everything onto the screen right here, so you can look at that. It should just say done uploading when it works. Okay. Is anyone having issues?
semicolon at the end of the digital read line. Right there. Yeah. Try to like what you. There you go. Yes, as we're finding out, yes, you definitely need those semicolons. Is anyone else having any issues? Alright, cool. Alright, so at this point, we're gonna step back just a bit from the code and focus on the circuit. I'm gonna leave the code on the board though, just because I can't put the camera on the board as of right now. So I'm gonna completely disassemble what we did earlier, and we're gonna build this from scratch. It's gonna be slightly different. So let me just move some stuff I don't need out of the way. All right. So again, going completely from scratch, we want to do a few things. The first, make sure that we're hooking up the correct pins. So again, the button pin and input, we want to connect to whatever number there. Mine is 4. So if you look on your Arduino, the digital pins 0, 1, 2, 3, 4, and connect a pin, your cable into that one. I want to use a white one. 0, 1, 2, 3, 4. So connect your pin into that. This is going to be what comes from the button to our Arduino. We'll come back to that in a second. We're also going to have LED2 is going to be another pin. So I would connect that. I used pin number 7. I just need more cables. Alright. So again, I've got this one plugged into pin number 4, 5, 6, and then another one into pin number 7. I would make these different color cables just to make life easier. Again, if you need to come look at it physically, you can kind of come over here. Just don't crowd too much. Again, I've also got a video where I'm doing my best to display it all on the screen right here. All right. So again, I've got it just from right now 4 to 7. I'm also going to connect the ground and 5 volts, just like that. So 4 and 7, ground and 5 volts. All right, yes. Yes. All right, so once you've got pins 4 and 7 connected, I'm just plugging one end into the board for right now. I'm also going to plug in the 5 volts and ground like we had before. I probably just should have left those, but oh well. So I'm going to go ahead and plug those back into the board like we've done before. So 5 volt, ground, 8, 9, 10, 11, 12, 13, ground. Yes. All right. So again, we got the 5 volts and the ground. Let me see if I can get some pictures here. So I guess going on the picture diagram, I'm also going to stick a button for right now, right in there. So I'm also sticking a button in there. And then as I go, I get the 5 volt and ground plugged into the breadboard. You could use the ground on this side as well. It doesn't really matter. But just 5 volts and ground. Now we're going to power up the switch. So again, we're going to go from plus to the switch, just kind of how I've shown you right here. Plus to the switch. All right, so once you've hooked up your power and ground, keep in mind you'll also have some cables that we haven't completely connected yet. We're connecting from the plus to the switch, the button, just like right there. Yeah, you'll need a few more wires for this.
So where do the 47 wires go?
We haven't plugged those in yet. Just leave those dangling for now.
Plus goes
to the pin. So you see how I have it on here? The one end is poking into plus, the other is into the button. I believe so. What we're going to do next is, before we had this connected to the ground, but now we're going to take this is our button pin, so 4. So we're going to take your cable connected to 4 and connect that to the other end of your button. Yes, so you'll see here I've got the same setup. So I've got that yellow cable, and then it's diagonally jumping the button, just like we did before, and it's connected back to the board here. This one's on pin 3, but on pin number 4. So it goes from the other side of the button back to pin 4. That looks right from this distance. We'll find out in a second. All right, so now, even though we can't see it, we have this set up so that it will respond to whether or not this button is pressed. So again, we've built this circuit up. It's getting the power from the board through this red cable, and then just by pressing the button, it's going to transfer that power. So it's either going to be high or low. But we're not quite done yet. We need to wire up an LED. Okay. Where'd my other LED go? Well, I lost an LED. Oh well. All right. So now, boop boop boop. Let's. All right, let's pull this up here. So now we're going to set up some things just so we get our LED working properly. There we go. This is what I want. So again, you get your same resistor and LED from before. And I'm just going to stick those into the board. So resistor, get in there, and LED. It doesn't particularly matter whether or not you stick the resistor before or after the LED. Either one's fine. I'm going to stick mine after. There we go. And now we're almost there. What you're going to do is take the back, just like this diagram I have right here on the screen. You're going to take the back end of the resistor and plug that into ground. All right. Again, that blue minus row on the Arduino. The very last bit will be connecting. You should have one more loose cable plugged into your Arduino from that very first step on pin number 7. What you're going to do is just plug that into the positive end of your LED. And we're going to find out if I did this right. What did I do wrong? It should go. Right, so it should go positive end of your LED to pin number 7. Do I have this backwards? No.
Positive means on the longest side, right?
Yes, the longer side. So it should go in there. Why didn't that want to work?
Like this.
In the damn holes. That to ground. That should be working. Oh, does the button need a resistor too? Did I goof? One moment. I guess we needed a resistor for the button, just the button that I skipped. So let's pull up. What is this? Brown, black, orange, which is 1, 0. Okay, so a 1,000 ohm. I think. Yeah, so you want to find a 1,000 ohm resistor, which is going to be. So we have the blue ones. Brown, black, red, I believe. There's one. Again, that's red, black, brown. Where'd you go? Black.
Brown, black, red.
No, go the other way. I'm trying to find one so I can. Brown, black. Where's my 1,000 ohm resistor? That's one, but that's not the right color to help you all. I don't. This system was not the best for organizing these. All right, but I think what we're missing is just a resistor in there. So let me double check that, and then I'll help you out. Oh, does it need to do it that way? Okay. I need to fix my instructions on this. If that's the case. Okay, why are you not working? It worked when I tested the... Yes. There. To ground. And then... I may just have my switch not properly hooked up. Huh? Alright, I'm running into more issues than I did the last time I did this, so give me one moment to troubleshoot, but then we'll have to wrap it up anyways. Okay. Here's a button I've got. Negative going to the resistor. Going to that end there. I've got it. The diagonal one going to positive. Diagonal one going to positive power. On this side. Then I've got my LED to set from 7 to the positive end. Setting at the resistor. Which is then just going back to ground. Okay. I'd do it exactly like that. Right, if this doesn't work in the next like 45 seconds, I'm just playing the video of the last time I did this, because we're going to run out of time. That goes into negative. Negative. Positive connects. Positive connects here. The same one here. The same one here, back to there. Alright. Yeah, there's something not wanting to work with that. But anyways, let me walk you through what should have happened. This is my first time ever teaching this unit in an actual class, so we're finding out what works and what doesn't work. So, what should have happened is going over some of the code here. Should have set a button pin and an LED pin and a button state. So the button pin was going to be an input and the LED being an output. What we're going to do is then just add in a line of code into the loop that says that the button state is going to just be rewritten with whatever the right here, that value from the variable was. We would then add in a conditional that says if the button state is high, we're going to write the LED pin to high. Otherwise, we're going to write it to low. Meaning if the button is pressed, the light's going to turn on. If it's not turned on, if the button's not pressed, we're going to let go of that. And I've got the code right here, which is basically the exact same thing as we did in the Arduino, only different pin numbers. So again, button pin, button state 0. In setup, we're just setting that to positive and negative, or input and output. And then we're saying, hey, button state, read the button pin here. And then if it's high, turn it on, otherwise turn it off. To build the circuit, we should have connected the button. And then also the power to the breadboard, just so we can have it working. We should have connected the power to one side of the button, so boom, right there. And then diagonally across, we should have connected this back to our button input pin. Let's make sure I got this in the right pins. 0, 1, 2, 3, 4, yep, and 7. Those are correct. So this should have been pin number 4 in our code. Yep, button pin number 4, button pin's an input. We're reading that. Oh, wait. I think I fixed it. Nope, I didn't fix it. Dang, I just noticed I misspelled something. Oh, I figured it out. But we're about to leave anyway, so I'm just going to play the thing. So this is going to be a button state. Hey, look, it works. Okay, so I'm going to again wrap this out. If anyone wants to see this working, you can come up and check this out. But all right, so we connected the far end of the switch of the button to the board here, and this is just adding in a resistor so that things don't get overloaded. I missed that step and forgot to tell you to get out the resistor beforehand. I don't think it's the most necessary thing in this little circuit, but that's what Arduino wants you to do. So at this point, you should have this set up. So you can check out the diagram, and that's where we'll be going from there. We don't need to worry about this part right now. What we'll be adding in last is this portion right here. So we're just wiring up an LED like we've done a few times already. Only instead of connecting it to power over here, we're connecting it to pin number 7 on the board. Because remember, based off of this code, we are writing pin 7 to be high when the button state is high, and we are then writing it to be low when the button state is low. This is just one basic example. You don't have to have an LED. This could be anything. You could have it respond to, hey, computer, play something over here, or have, the light turn on, the speaker play a sound, or adjust the microphone, or you can have it respond to whatever you wanted. Yes? Yes, what I want you to turn in, we didn't get much into making the diagram because we're about to run out of time. But under today, the 21st, what I want you to turn in is go into your Arduino app and just copy your code and paste that into a Google document and turn that in. You should have just a few minutes, plenty of time to get that done. You can ignore the diagram portion. Yes. So again, what you're going to turn in for today's grade, I've got this Arduino code right here. This one I have fixed, so it will work. You're going to copy and paste that into a Google document and turn it in. So again, we've got a few minutes to get that up and going. Can I just save? I'm just going to check one thing and then, okay, that's how that works. All right, I'll leave that on the screen, so again, you can just make sure your stuff lines up, and we'll go from there. When we come in on Friday, I'll walk everyone through this really quickly and make the diagram for it, but we're getting there. Again, we're finding out what works and what doesn't work. And then again, make sure that before you leave, you've packed up your Arduino kit. That's part of the reason I got rid of that turn in the diagram part, because we won't have time to do all that. If you have any questions or concerns, let me know. Again, we'll kind of wrap up the digital stuff on Friday and start talking about analog things. So that way our code will respond to sensors and stuff like that. Flip it over. So so it's upside. Yeah. So there's a little bit of space between the board. You may have to change where things are underneath it. There's a little bit of space between the board, the Arduino, and the breadboard. So that way you can fit that plastic runner in that spot. All right, I'm going to end my little streaming thing. Hopefully this will be helpful for people.